SAP InfiniteInsight recommendation can be used to generate product or service recommendations for customers by analyzing their behavior and other details and comparing these with the details and behavior of other customers. The output of a recommendation model includes a set of recommendations for each customer in the dataset. First, we need to select the dataset to analyze. For this example, we'll use a dataset from the samples folder that's created when InfiniteInsight is installed. Next, we need to provide a data description to correctly identify the characteristics of the data, such as the data type for each column. We can click Analyze to get SAP InfiniteInsight to generate a data description automatically, or we can load a separate description file. Note that you must validate the results if you use an automatically generated data description. For this example, we'll load a description file. Now we can see the list of variables in the dataset and their associated data types. In the column roles area, we can specify the columns that contain customers and items purchased. These columns have been identified automatically. We can also specify a weight column if desired. With no weight variable, the algorithm looks only for how many transactions contain any two specific items. With a weight on quantity, for example, we could also consider the number of each item sold, which might affect the recommendations generated. For this example, we will not use a weight variable. In the time period area, we can specify the column that contains date information. This column has been identified automatically. We can also specify starting and ending dates for analysis if desired. In the best sellers area, we can choose the sales threshold that defines an item as a best seller. For this example, we'll count any item with sales over 500 units as a best seller. These items will be excluded from recommendations because they already sell well. Here we can apply additional settings for a recommendation model. InfiniteInsight recommendation analyzes the dataset to create a number of rules describing purchase combinations. We can set a maximum number of iterations of analysis for generating rules, as well as the minimum number of times a purchase combination must occur before the rule is used to make recommendations. For example, if a rule states that purchasers of running shoes also buy striped socks, the minimum support is the minimum number of times that this purchase combination must occur in the dataset before the striped socks will be recommended to individuals who purchase running shoes. On the Filters tab, we can restrict recommendation rules based on their minimum confidence or predictive power. Each rule has two parts, an antecedent or initial purchase and a consequent or recommended purchase. Minimum confidence concerns how often the consequent condition must occur when the antecedent condition occurs. For example, if half of the purchases of running shoes are accompanied by the purchase of striped socks, a rule recommending that purchasers of running shoes also purchase striped socks would have a confidence level of 0.5. Minimum predictive power refers to how well the consequent is explained by the antecedent. For example, if most customers purchase striped socks regardless of what else they purchase, the rule that people who buy running shoes also buy striped socks would have low predictive power. For this example, we'll accept the default settings. On the Candidate List tab, the Target Event Required option is for use with a co-location feature that's not being used in this example, so we'll leave this option turned off. On the Final Selection tab, the Max Top Nodes option enables us to filter best-selling products from the recommendations list, since these products don't need recommendations in order to sell. For this example, we'll use the default setting. Here we can review the settings before generating our model. Here we can see a high-level summary of the modeling results. Next, we'll review some of the debriefing tables to see the results in more detail. Here we can see the items classified as best sellers based on the threshold we set. Here we can see the most popular items that were not classified as best sellers. Now we'll view the graphs that have been generated by the model. Here we can visualize the modeling results by item purchased or by user. Here the list of users is sorted by weight, which is based on the number of transactions. We'll view the user with the most purchases. At the center of the chart is the user, with lines linking the user to the product types purchased. The width of the lines reflect the number of items purchased within the product type. The thickest line connects to pullovers. Next, we'll view all of the users who purchase products of this type. Next, we'll look at the other product categories most commonly purchased by customers who bought pullovers. Here we can see that the strongest links to the pullovers category are with shirts and trousers. We can expand the nodes to see the network of links between these categories at a deeper level. Next, we'll look at the list of recommendations generated for an individual user. Note that there are options to eliminate recommendations that the user already owns, to include or leave out recommendations of best-selling items, and to keep only the top recommendations. For this example, we'll use the default settings. Here we can see the top 5 recommendations for the customer, along with the confidence level of each rule. Next, we'll save the model. For this example, we'll save the model to the same location as the data source. Next, we'll apply the model to generate an output that includes the recommendations for each transaction. Now we need to choose the dataset to apply the model against. Note that the application dataset must contain the customer column and the item purchased column. Any additional columns will be ignored. Also note that the transactions must be the same as those used to create the model. Next, we need to enter the name of the output generated by applying the model. Now we'll view the output. The output includes the user ID and item purchased columns from the original dataset, along with a column specifying the relevant recommendation rule number, the recommended item, the column the recommendation is based on, the confidence level for the recommendation, and a KX index column. Note that because we asked for the top 5 recommendations for each purchase, each row from the original dataset is repeated 5 times, once for each of the 5 recommendations. The recommendations are listed in descending order by confidence level. You now know how to generate recommendations in SAP Infinite Insight. For more SAP Business Intelligence tutorials, visit sap.com/learnbi.